If you still not subscribe my channel, click on subscribe button for more videos. In previous video I told you what is the importance of color checking through a machine. Go through below link for that. What is delta E? Now for further details let's talk about what is CIELAB, CIELCH and CMC. I give you this information in brief for your understanding. Color measuring instruments and industry-accepted color difference systems are widely utilized in industrial color acceptability applications. Colorimetry is used to supplement the visual evaluation process, as it provides a way to consistently quantify color differences, and thus facilitate the management of product color tolerances. Color tolerancing systems are used in the management of production and customer acceptability activities. The tolerancing systems discussed in this data facts are CIELAB, CIELCH and CMC. CIELAB in acceptability applications. Since its publication in 1976, CIELAB, CL*AB and CL*CH, has been extensively employed in the management of color acceptability. However, the desired perceptual uniformity of CIELAB color space has not been realized. Studies have shown that as the chroma of a color increases, CIELAB increasingly overstates the magnitudes of perceived chroma and hue differences. CIELAB color space is also non-uniform. Regarding hue angle, although the specific nature of the non-uniformity is not yet definitively determined, the primary limitation on the use of CIELAB in acceptability applications results from the non-uniformity of the color space. CIELAB color difference. The CIELAB system describes and orders colors based on the opponent theory of color vision. The opponent theory is that colors cannot be perceived as both red and green at the same time, or yellow and blue at the same time. However, a color can be perceived as a combination of red and yellow, red and blue, green and yellow, or green and blue. L is a measure of lightness of an object, range from 0 to 100. A is a measure of redness or greenness. B is a measure of yellowness or blueness. Note, A and B approach 0 for neutral colors such as white, gray and black. The drawback to using CIELAB in tolerancing systems is that the rectangular acceptability volumes do not conform well with visual experience. The visual acceptability volume in CIE 1976 space typically takes the form of an ellipsoid, whose minor axis aligns in the direction of changing hue. Since both the shape and alignment of the LAB volume do not agree well with visual experience, colors near the edges of the volume may be calculated as acceptable although visually judged unacceptable. CIELCH color difference. Colors can also be described and located in CIE 1976 color space using the method of specifying their L, C, and H coordinates. In this method, L coordinates are the same as in LAB, while the C and H coordinates are computed from the A and B coordinates. The same color is still in the same location in the color space, but CIELAB and CIELCH are two different ways to describe its position. Many C system users prefer the LCH method of specifying a color, since the concept of hue and chroma agrees well with visual experience. L is a measure of lightness of an object, range from 0 to 100. C is a measure of chroma, saturation, and represent distance from the neutral axis. H is a measure of hue and represent as an angle ranging from 0 to 360. Angle from 0 to 90 are reds, oranges and yellows. 90 to 180 are yellows, yellow greens and green. 180 to 270 are green, cyans and blues. 270 to 360 are blues, purples and magentas and return again to reds. And H value is equal to 360 reported as 0. Cmc Color Difference. The Cmc Color Difference formula is based on the colorimetric principles of the CIE 1976 system. It is typically employed as a color tolerancing system in industrial applications. Cmc Color Difference (CMC), a modification, transformation, of CIELCH color difference, has proven to be a useful measure of the commercial acceptability of colored products. A color tolerance is a limit to how big the difference in color between a sample and standard is allowed to be for the sample to be considered acceptable. Tolerance values should correlate to the human eye so that color is both visually and numerically acceptable. The Cmc Tolerance System is recommended because the ellipsoids in this system are based on the color discrimination threshold of the human eye. This system was established to address the weaknesses of other tolerance systems and improve accuracy. The Cmc Tolerance System is often used for high-accuracy pass-fail assessments and quality control inspections within manufacturing environments to ensure standards are met. This is because its formulae more closely aligns with how the human eye sees color, adjusting to greater shifts in lightness than in chroma and hue. Calculating the lightness, chroma, and hue attributes of the standard color, its formula creates an ellipsoid around this standard within the color space. Color that falls inside this ellipsoid is considered acceptable, while color that falls outside of this ellipsoid is rejected. The size and shape of the ellipsoid are dependent on a number of factors including where the standard color falls within the color space, the defined ratio between lightness and chroma attributes, L, C, and the established commercial factor, CF. The CF is the tolerance value, or limit to how big the difference in color between a sample and standard is allowed to be. If the CF is 1.0, for example, then the total color difference, ECMC, between the sample and standard would need to be less than 1.0 to pass inspection or be considered acceptable. This helps maintain color consistency and accuracy throughout the supply chain and from one batch of material to the next. SL, SC, and SH are CMC weighting functions that adjust the CIE differences delta L, delta C, delta H depending upon the location of the standard in CIE 1976 color space. A user of the CMC formula usually sets values for the L and C parameters according to practice in his industry. L and C are numeric parametric factors that permit the independent weighting of lightness delta L, and chroma delta C, differences, relative to the hue delta H difference. Current practice is that C is set to 1 for all industries, and L is set to 2 for textiles, and to about 1.4 for paint and plastics applications. Examples of CMC reading, these are textile fabric reading. In industry, to keep the color continuity in a same quadrant, we use this delta E CMC readings against standard. Thanks for watching and subscribe for more videos.